Welcome to Sairam Triple E YouTube channel. Let us discuss first module of your high voltage engineering subject, continuation of dielectrics. In that we have a gas as a insulating media, right? So the simplest and the most commonly found electrics are gases, right? So like nitrogen, carbon dioxide, and then freon and sulfur hexafluoride, SF6. SF6 mostly and then widely we are using in the circuit breakers, right? So most of the electrical apparatus use air as the insulating medium, and a few cases other gases such as if suppose air is I mean like not using, we are preferring gases, right? So more advantage compared to air in the gases, right? So I mean like breakdown and flash over everything will be high in the gases, and various phenomena occurs in the gaseous electrics when voltage is applied. When the applied voltage is low, a small current flows between the conducting electrodes and the insulation keep its electrical property. Suppose if it is air or whatever other materials, what happens? It will not be coming back to their again, real position. I mean, again, re positions. So in the oil, it will come in the retake like that, or reuse, and then it will come to a real position. I mean reposition. Uh, Whereas is applied voltage is large, the current flowing through the insulating increases very sharply, and an electrical breakdown occurs. Right. So a strongly conducting spark formed during the breakdown practically produces a short circuit between the electrodes. So if suppose if you conduct the experiment high voltage engineering laboratory, there is a aisle transformer aisle dielectric strength testing, and we are placing two electrodes, and then there is a spark occurs in between them. And similarly for air also, there is a two spheres or two flat or pointers we are using, and just we are making a breakdown how what is the voltage, what is the strength, we are going to check by using a laboratory. Similarly, a strongly conducting spark formed during the breakdown practically produces a short circuit between the electrodes. Right. The maximum voltage applied to the insulating at the moment of breakdown is called as a breakdown voltage. Two types of electrical discharge gases: non-sustaining discharge and self-sustaining types. Right. So, collision process, ionization process at a normal temperature and a pressure, gas acts as a good insulating material. The condition you should remember as a normal temperature and a pressure. When high voltage applied between the two electrodes immersed in a gaseous medium, the gas becomes conductor and electrical breakdown occurs. So if you just conduct an experiment like two spheres or two electrodes placed inside the oil, and if you pass high voltage or like high current, what happens if suppose breakdown occurs in between those two electrodes? The conduction will occur, right? So in the oil, so that's one thing. And ionization by collision are two types: elastic collision. And elastic collision is a collision in which there is no net loss in kinetic energy. The system result of the collision. Okay. An inelastic collision, a collision in which the total kinetic energy of the colliding bodies or particles is not the same after the collision as it was before, opposed to the elastic collision. So next we have a process that are primarily responsible for the breakdown gases. One is a primary ionization process, secondary ionization process. So the primary ionization process, we have ionization by collision, photoionization. So collision must be there. If suppose one to one ions movement will be there, means definitely if suppose collision occurs, then only energy created. So photoionization. So when light hitting into the particular material or particular plate, what happens? Ionization will occur. Secondary ionization process. Secondary. So primary is with a direct ionization process, but secondary is a reverse reactions will be there. Electrons emission due to the positive ion impact. So emission of electrons by the metal surface, or I mean like different types of materials. Thermalization, heat will be there. Heat gets like gives us to conduct the process. Ionization by interaction of metastable and neutral atoms. Electrons are detachments. Okay, next there is a primary ionization. Ionization by collision. Ionization is defined as the process of leaving free electrons from gas molecules with the continuous generation of positive ions. In the process of ionization by collision, a free electrons collide with a neutral gas molecules and gives rise to new electrons and positive ions. If you consider low pressure gas column in which electrical field E is applied across two plane parallel electrode. So if the energy E is gained during this travel between the collision exceeds ionization, potential Vi is, which is energy required to remove an electrons from its atomic shell, then ionization take place. This process can be represented as electrons plus A. Epsilon is greater than Vi. The process, okay. Electrons negative and A plus E negative, where A is the atom, A plus is the positive ion, and E naught is the electrons. E electrons negative. A few electrons produced at the cathode by some external means, say ultraviolet light, right, falling on the cathode, ionize neutral gas particles, producing positive ions in addition to electrons. The additional electrons then themselves make ionization collision, and thus the process repeat itself. So repetition must be there. Okay. Next, there is a photoionization. Photoionization, the ionization caused by the cosmic radiations. Photons is called as a photoionization. Photoionization occurs when the amount of radiation energy absorbed by an atom's molecules exceed its ionization potential. There are several processes by which radiations can be absorbed by atoms or molecules. They are excitation of the atoms to higher energy states. So the continuous absorption by direct excitation of the atoms, dissociation of diatomic molecules, or direct ionization, this reversible process can be expressed as Hv is equal to H lambda. Okay, the A reversible process, A plus electrons. So E is always greater than AI. I mean condition of breakdown, whereas E is H nu. I mean a Planck's constant. H nu Hc by lambda. Here H is a Planck's constant. C is the velocity of light, and lambda is the wavelength of radiation. So this is a diagram. So ultraviolet is light falling into this cathode. What happens? There is a recombination take place, and there is a current limiting resistor is present. What happens? It limit the current flowing from the battery or source. Adjustable HV source, adjustable high voltage source also will be there, and ammeter will be there to measure the current and the cathode and ultraviolet rays. The higher the ionization energy, the shorter will be the wavelength of the radiation capable of causing ionization. Secondary ionization, the process of formation of secondary electrons after the completion of ionization process, collision and photoionization. Electrons emission due to the positive ions impact. Positive ions formation is due to either ionization by collision or photoionization. Positive ions moves towards the cathode, everybody knows, right? The secondary ion forms such a way that the total energy is greater than 2 work function, where total energy is equal to kinetic energy plus ionization energy. When positively and negatively charged particles present, recombination take place. So I told you, right, there is a recombinations will be there. If suppose if you pass electricity, if you pass high voltage, what happens? So movement of electrons must be there, and ionization process will be occurring. Next we have a thermal ionization. Okay, thermal ionization. At the high electric stress, the gas filling gap between the electrodes is heated up. Right, thermal ionization in sense, if suppose a thermal oven, just the best example, um, like uh, heating inside the chamber or whatever. The gas of at a high temperature, some of the gases molecules acquire high kinetic energy. The collision between the molecules creates ions due to release of electrons from the neutral particles. The electrons and other high-speed molecules in a turn collide with each other and release more electrons. Thus, the gas get energized. right? So this is a concept we discussed in this video. Next class we'll discuss about thousand equations, thousand derivations, everything. Okay.